Hi, grade 11s. Today we are going to continue with some of our revision on analytical geometry, hence written revision part 2. Recall from the previous revision, we looked at formulae for finding the midpoint between 2 points, or the gradient, we use that one, or the distance between 2 points. Today we are going to extend this section. Let's look at some of the examples. Suppose example is given like this. They say the diagonals of a parallelogram ABCD intersect at point P, where A, B, and C and D are these coordinates given. Now, in some of the examples, a diagram won't be drawn for you. You'll have to draw the diagram. In this case, I've drawn a diagram for a parallelogram ABCD, and then with the diagonals by intersecting at point P. I've drawn it like this. So that's what you can do as well. Now the things that you need to know when you are dealing with polygons. When we label a polygon, we are expected to label it clockwise, anti-clockwise or clockwise. We do not zigzag. You can start here, but points must follow to form a circle. You can start over there and do that as well. You don't zigzag. You continue like to form some kind of a circle. Now we said the diagonals, which is this red line and this green line, they intersect at point P. So they intersect at this point. But they said this is a parallelogram ABCD, so I can put point A there. It doesn't matter because these things are not drawn to scale. If A is there, I put there, it doesn't matter. But as long as it's clockwise or anti-clockwise, you finish the circle. So the point A given as a -9 is to 8, and point B, if I like, I put point B over here, it's a -13 is to 0. So on anti-clockwise in this case, it's -3 is to 2 according to that, and the coordinates of D are x as y, x is to y, like that. Okay, so this diagram is drawn. Now there are things that could be a way of guiding you to answer some of the questions that are given. In this case, they talk about the diagonals. So there's a diagonal, and if this is a parallelogram, we should know from grade 10 that the diagonals bisect each other. Although they meet at point P, they bisect each other at point P, meaning that this length is equals to that small length there equals that small length, and that one there equals that one there. So I can take like this and like that. Okay, now they say we must calculate the coordinates of point P. Now they don't tell us anything. We've got to think. We can see that P is the midpoint. It's a midpoint of this line AC, and we said they want us to find the coordinates of P. Find the midpoint. We used this formula previously, so we can say here we know that P will be x1 plus x2 over 2 is to y1 plus y2 over 2. So the P will be x1, we're talking about the coordinates there, so x1 could be a -9, then plus a -3, and that is divided by 2, and then y1, it's 8 plus a 2 and divided by 2 and close. So if I simplify this, what do I get for the coordinates? I can put in the calculator as usual. It's a fraction there. So it's a -9 plus a -3 and then over a 2. What am I getting? -6. So I've got -6 there. And then this one here, I can do it by 8. 8 plus 2, that is 10. 10 divided by 2, that is 5 is to 5, meaning that the coordinates there is -6 to 5. It's always wise to write it down. It may help you in future. So it's -6 is to 5. In this case, it will. Check the next question. It says, calculate the coordinates of point D. Now we want to find the coordinates of point D. We can see again in the red line that P is the midpoint. Now, when we are finding P, the x value here added with the x value give us the middle x value, divided by 2 give us the middle x value. It's similar with the y value. The y value there plus the y value. If I divide it by 2, I get the middle y value. Now, in this case, we already have the y value in the middle and the x value in the middle. So we don't know that outside there. So to find the outside one is that plus that divided by 2 will give us that. So that's what you do. So minus 13, if I add that x there and divide by 2, I will get the middle value, which is minus 6. Which means that I can solve for x here. If I cross multiply, it's minus 13 plus x would give you 2 times minus 6 is minus 12. So x is equals, if you take minus 13 to this other side, you'll get x equals 1. Similarly, if I want to find the y value of point D, I'll deal with the y values. So the y value there, which is 0 in this case, plus the y value over there, which is y, divided by 2 will give me the y value in the middle, which is 5. Is equal to 5. If I cross multiply to solve for y, I'll get 0 plus y is equal to 10, which means that y is equal to 10. Therefore, the coordinates of D, because it was x and y, so it's x and y there, will be 1 is to 10, 1 is to 10. Done. Let's look at another question that can be asked. I can ask you a question like this one here. You can say, determine whether each pair of lines is parallel or perpendicular. All right, so these are lines. To find it, you must use your gradients. All right, so there you must use gradients here. Use the gradients to decide. Okay, we'll see how we decide that. If we look at the gradient of this line here from grade 9 and grade 10, this number here is the gradient and this number is our gradient. The gradient, you find it if you've got the equation of a line in y is equal to mx plus c. So y must be on its own is equal to mx plus c, and the m is your gradient like that. We can see here the m here is at 3. So if we like that, so the gradient here is equal to 2 over 3. And the gradient over here is also 2 over 3. So the gradients are the same. So because the gradients are the same, we say therefore the lines are parallel. So if the lines are parallel, it means that their gradients were equal. Let's look at this one here. We said that to work with these things, we need the equation to be in the form y is equal to mx plus c. Then we can decide. In this case, you can see that this is not in the form y is equal to mx plus c. So because there's a 5 here, I must get rid of this 5. If I get rid of this 5, I must divide both sides by 5. So I've got 5y divided by 5 is equal to x divided by 5 plus 15 divided by 5. So this goes off. So the y there, y will be equal to this x over 5. Remember, same as 1 over 5x. Then plus 15 over 5 is 3. So we've got the gradient here as 1 over 5. Come to this one. This will be solve for y in this format here. So I'll have y is equal to, take this across, is minus 5x, then plus 2. So y is equal to, now check the gradient here is minus 5. The gradient here is 1 over 5. Now, if you want to decide whether the lines are parallel, the gradients must be the same. Now here the gradients are not the same. Now another thing that you must do now is check what happens if I take this gradient and multiply with this one. Take this gradient. If I multiply this gradient here, 1 over 5, I multiply with this gradient, which is minus a 5. The answer that I get is minus 1. Since the answer is minus 1, we say therefore the lines are perpendicular. Perpendicular. So lines will always be perpendicular if the product of the gradients give you minus 1. We'll say the lines are perpendicular. Okay? Now, let's look at this one here. They say refer to this diagram here. So diagram is drawn like this. They say show that QS, this symbol PR. What does this mean? It means that perpendicular is a symbol for perpendicular. So we've got to show, we must show that QS is perpendicular to PR. So that is what we must show. And we've just said if lines are perpendicular, it means that the gradient is minus 1. All right. So if we want to show that the lines are perpendicular, we must find the product of the gradients, right? So this line here has got its gradient, which you can find, and this line here has got its gradient, which you can find. So if we multiply these gradients, and if the answer is -1, then we'll know that the lines are perpendicular. That's fine. So we'll find the gradient of the line QS, and we will multiply it with the gradient of line PR. Some may ask, what is this now? M is for the gradient of which line? M is the gradient of which line? So M, gradient of QS, gradient of PR. So we'll multiply them. We know how to find the gradient again. To find the gradient, we use the formula. Always remember, y2 minus y1 over x2 minus x1. So I'll just write that. y2 minus y1 over x2 minus x1. So we'll multiply with the gradient of this one, which is y2 minus y1 over x2 minus x1. So dealing with QS, there is QS. What is y2? QS is this line over here. So y2, there is 8. Is 8 minus y1. y1 is a minus 4 over 12 minus x1. x1 here is minus 4. Multiplied by, now dealing with PR, the gradient of PR, I'm going this line now, PR there. So what is y2? y2 is this, okay? So say 2 minus y1. y1 is a 5 over x2. x2 is 0. 0 minus that one. Subtract minus 2. So what is the answer that I get? I don't want to make mistakes. I can use a calculator as usual. So a fraction and plug these things in. So it's 8 minus, there is a minus 4 over there, 12 minus, that is minus 4, close, there, multiplied by fraction, there is 2 minus 5, there at the bottom, 0 minus 2. Of course you can do this like mentally. What's my answer? Is correct? 8 minus, say there, 0 minus 2, 0 minus minus 2, and then this was 2 minus 5, and then here was 8 minus minus 4, and then this was 12 minus QS, 12 minus minus 6, that is minus 6, I'm sorry, over there, minus 6. Now let's check. Let's check in the calculator space there, put things correctly. The calculator, there you go, that's supposed to be minus 6. They've got minus 6 over there. Let's check the answer. The answer is minus 1. Aha, it's minus 1. Now the answer is minus 1. The product of the gradient is minus 1. Then we can conclude and say, therefore, line QS is perpendicular to line PR. Conclude that thing there. Now, on your own, from your grade 11 Siavula textbook, do these problems similar to the examples that we did. Chapter 4, 4.1 revision, exercise 4.1, just do numbers 9 and 10. It should be easy to do. Good luck, ladies and gentlemen.